So moving on and talking a little bit more about logs, we need to talk about how to graph them. So just to start off, if you wanted to go ahead and find the natural log of 3, you would write that as f of x equals natural log of 3. And if you type that in your calculator, you're going to get 1.10. If you did the same thing with 24, you plugged in 24 for x and you did the log of 24, you're going to get that it's approximately 1.38. So we have two graphs below, and these graphs represent two different logarithmic functions. And the first graph represents a graph whose function is written in the form of log base b of x, where b is a number that's bigger than 1. So it could be 2, 3, 4, 5, 37. It's just something bigger than 1. Well, this graph is an increasing graph. The second graph is also written in the form of log base b of x, but what's different this time is that b is something between 0 and 1. And if you look at this graph, it's no longer increasing. This graph is actually a decreasing graph. So if b is bigger than 1, it's increasing, and b is less than 1, and it is decreasing. So when you look at the shape of a log graph, logs are going to look like this or this. They're always going to be curved. They are going to increase if b is greater than 1. So they're going to look like this. And then they will be decreasing if b is between 0 and 1, which means that they're going to look like this. They're going to be curved down. So the x-intercept, where the graph crosses the x-axis, no matter what, if it's log base b of x, is going to be at the ordered pair 1, 0. There will always be a vertical asymptote at the y-axis. The domain will be all positive real numbers, so everything bigger than 0, and the range will be all real numbers. This will be true every single time. The range will always be all real numbers. Our domain, our vertical asymptote, and our x-intercept, those things are going to change depending on what our function looks like. So moving on to our checkup, we're going to do problems, the odds as usual. So number 1 says to find the domain and the range of the function. Well, we said that our range for every single log function is always all real numbers. That's going to be true for every single log function. As long as our function is just the log base something of x, then our domain will be all positive numbers, which we can also write as x is greater than 0. So that's going to be the case for all the problems that you have to do today. The domain can change from time to time, but it will not for anything that you are working with, so we're not going to worry about that. So you need to know that the domain and the range of all logs is going to be these two right here. So for number 3, it asks us for the domain and the range. Well, my domain is x is greater than 0. It's all positive numbers. And my range is all real numbers. Numbers 4 through 6 ask us to find the x-intercept of the function. If you'll recall, the x-intercept of all log functions that are written in this form is always 1, 0. So every single one of these has an x-intercept of 1, 0. Now our last part, 7 through 10, is a little bit more difficult. It's asking us if the function is increasing or decreasing. So if it's increasing or decreasing is determined by this number, our base, which I'm circling all of these in blue. The rule says that if that base is bigger than 1, that means it's increasing. And if our base is between 0 and 1, that's what this notation means. It means that b is between 0 and 1, that it's going to be decreasing. So all you have to do is decide, Is the base between 0 and 1, or is the base bigger than 1? So looking at number 7, our base is 8. 8 is bigger than 1, so it's going to be an increasing function. And then number 9, we're looking at our base, which is 2, and 2 is bigger than 1, so it is, again, an increasing function.